Exploring the deep ocean floor for microorganisms and various hydrocarbons that are indicators of oil or gas is a daunting task. It involves large vessels, miles of cable, and powerful winches to retrieve only a small sample of sediment. When exploring the ocean subfloor at more than 2,000 feet, there are many unknowns, and the process can be ineffective because of costs, time lost, and contaminated sediment samples. Lloyd Wenger, one of the world's leading geologists from ExxonMobil, explains the challenge.
We contract ships to go out, specially equipped ships, virtually oceanographic research vessels with booms and winches and thousands of meters of cable to contract a, say, 30 or 40 core survey in a remote part of the world. You're spending upwards of a couple $1 million or perhaps much more. So it's a very expensive proposition, but it can give you a lot of useful information.
Galen Verhulst from Millennium Technologies came up with a new concept to capture soil samples from the ocean floor with an untethered device.
The trick to this old deep sea probe, you can go down and take a sample, but to have a sample contained at the bottom, the same pressure as you bring it up, is the trick to this game that has the interest of the oil and gas companies. It must be a contained sample, so it can't leak on the way up. Current conventional methods, they do a core, and as the core comes up, it leaks. All the hydrocarbons leak out all the way up, and it takes several hours to get to the surface, so it's all bled out. With our probe, we go down to the surface, we open the valve, take the sample, shut it, and bring it up. And they measure what they call interstitial waters. You don't see like oil and gas bleeding off in your hand. There's a relationship between certain hydrocarbons, they fingerprint it, and they can do pattern recognition, infer that maybe there's some reservoirs down below.
The device was built in partnership with the Kansas City plant, Millennium Technologies, and scientists from Russia. The Russians participated through the Department of Energy's Global Initiatives for Proliferation Prevention Program, GIPP, which engages scientists from the former Soviet Union to partner with American companies in developing advanced technologies.
Our project, the Deep Sea Probe, started about 4 years ago. The reason of the project was to design and develop the Deep Sea Probe as a prototype for the equipment. They have a very close cooperation with Kansas City plant and other partners that help them to develop and build the system. He hoped that we are going to continue working in this project because they already have ideas how to build a better unit and more robust, and will be working much better.
GIPP is a proven model for technology commercialization involving partnerships among U.S. industry, U.S. national laboratories, Russian, and other former Soviet scientific institutes. Researchers, scientists, and technicians recently tested the new concept called the Deep Sea Probe off the coast of Miami, Florida. The June 2011 test was supported by Chuck McDonald, who was contracted to provide a versatile machine shop for preparing and final assembly of the Deep Sea Probe. Chuck also provided a boat to deploy the probes for the test. When all of the preparation work is completed, the probe is dropped from a vessel in a deep sea location where a survey of the ocean floor is desired. The probe penetrates the ocean subfloor sediment and collects a pressurized sample. Weights are then released and the probe returns to the water surface. It immediately sends a GPS location, flashes a strobe light, and reflects radar signals via right-angle planes located on the float lid. The probe can be easily retrieved. Data from an accelerometer measures drift as the probe rises to help determine the exact location on the sea floor. Additionally, a pressure sensor indicates the depth of the probe. The probe arrives back on board with samples of microorganisms and other sediments that would indicate the presence of oil or gas. The samples are captured in containers that maintain the same pressure as the ocean floor.
Petroleum geochemistry, particularly looking at seeps as providing real direct evidence on the presence and characteristics of petroleum, from the economic standpoint. And I look at the DSP as, even going beyond that in the ability to further explore the subsea. I mean, we know more about the moon than we do about the bottom of the sea. Just a great platform.
We know what the concept's proven. We still got a few bugs to work out, but this is just 10 years coming down to one point. So I just can't tell you what I felt when that thing popped up the first time, even at a shallow depth of 10 feet. We're going out deeper here today, tomorrow, to 2,000 feet, and that'll be the real test, but I have every confidence it's a proven concept now. And that's what happened today. We proved it'll work.
The Deep Sea Probe, a concept that shows promising results for effectively and efficiently collecting ocean floor sediment samples for oil and gas exploration.